Hi, Dr. Pitcher here, and in today's lecture we're going to learn about naming alkanes. And these rules for nomenclature apply in general to other classes of compounds, only some of the details will be a little bit different. And we'll take a look at those just a little bit. All right, so alkane nomenclature. And the type of nomenclature or the system of nomenclature that we're going to use is called IUPAC, and that stands for the International Union of Pure and Applied Chemistry. Now, what is in a name? What's in a name? There are several parts to a name, and I'll go ahead and use the same terminology that is in the text. So we will have a base to the name or a root, which the text calls a parent. We will have a suffix. We will have a prefix or prefixes. Let's write the right word, Wayne. Prefix. And then we will also have, let's try it in green here, a locant. Okay, let me just see. So our locant is, well, no, we'll start with the parent. The parent or the root is the number of carbons in the main chain of the molecule. The suffix gives us the functional group. The prefix or prefixes give us the substituents. And the locant gives, or there may be multiple locants. Let me put that in parentheses here. The locants give us the locations of our substituents. So these are the parts of a name. Now, there are some rules for nomenclature. So let's go ahead and take a look at these rules sort of step by step. Oops, let me add a page here. There we go. The first thing that you want to do is find the longest continuous chain of carbon atoms. And that is going to be the name of the parent chain. Okay, so let's say just as an example, let's say we had CH3, CH2, CH, CH3, CH2, CH3. So our longest continuous chain here is straight across here, 5 carbons. Okay, it wouldn't be 1, 2, 3, 4, or 1, 2, 3, 4. It's 1, 2, 3, 4, 5. So with 5 carbons, this is pent for our root. Now we already know, since we're dealing with alkanes, this is alkane nomenclature after all, our suffix is going to be ane. So for all of the names that we are looking at in these 2 chapters, the suffix is always going to be ane. All right, so what's the next rule? Well, first of all, there's a couple of little caveats here. What if we had this? What if we had, let's see here, CH3, CH, CH3, CH, CH3, C, H2. Just think about this for a second here. Let me back up just a sec here. There we go. Oops, that was the wrong thing. Sorry about that. So CH2. Let's make this a little shorter here, sorry. Actually, I do want that CH2, CH3. Okay, there we go. So we could have 1, 2, 3, 4, 5, 6. But we could also have 1, 2, 3, 4, 5, 6, like so. So how do we decide which it is? Well, first of all, we know that it is going to be hexane. Which one do we choose between? Well, we're going to pick actually the yellow one here, because our rule is that if we have 2 different chains that are the same length, we want to choose the one that has the most substituents. Okay, and so our green one here just has 1, 2 substituents. Okay, one of those substituents has another branch, but our yellow one has 1, 2, 3 substituents. So our next rule here is choose, maybe I'll phrase it this way. If chain length equal, choose chain with more substituents. And substituents are simply branches. All right. So what's our next step here? Okay, we will want to number our main chain. And we're going to start at one end of the molecule. Specifically, we're going to start at the end of the molecule closest to a substituent. Okay, so just to look at our pentane here, it really doesn't matter which one we start with, because I could go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. The branch is still at carbon 3. So let me draw a different example. So now my longest chain here is 1, 2, 3, 4, 5 carbons. And I'll go ahead and I'll number these, and I'll number them in red. 1, 2, 3, 4, 5. Write that 5 a little nicer there, 5. Okay. I would not want to do 1, 2, 3, 4, 5. That's not what I want to do. So let me cross those out there. In fact, actually, I'll just go ahead and erase them. So again, we're starting numbering at the end closest to our first substituent, our first branch point. And then we're going to assign a number to the substituent to see where it's located. Basically just figuring out which carbon has the substituent attached. Okay, so once we figured out which carbon it's attached to, so our CH3 here, our methyl, is attached at carbon 2. So now we can identify our substituent, and we will stick the number in front. So this would now become 2-methyl pentane. Okay, because this guy here is a methyl group, which we saw in the previous lecture video. Okay. So I think the rules are reasonably straightforward. It's just a matter of the more complex a molecule gets, the more you have to pay attention to the rules. So some more things to note here. Oops, let me add a page. So for multiples of a given substituent, we're going to use prefixes. We'll use di, tri, tetra, penta, etc. And that is for 1. Oh, I'm sorry, not 1, Wayne, come on. That's for 2, 3, 4, 5. I'll just put little arrows there. And then another thing to remember is that you still want to indicate which location, or rather which carbon, each substituent is attached to. Another thing to note is for multiple different substituents, we'll go ahead and list those in alphabetical order. And then it's listed not based on these prefixes, but rather the name of the substituent. So ethyl would be before methyl, etc. So let's just go ahead then, and let me go back to this guy here. And what do I have? Okay, so I want to figure out my longest continuous chain, and it happens to be just straight like that. So I can go ahead and number these carbons, and I'll start at this end on the left here because it enables me, I feel like oh, yeah, there we go. That works. That's fine. It enables me to have the most substituents. So I've got 1, 2, 3. If I had gone 1, 2, 3, 4, 5, I'd have 1, 2 substituents, one of which had another branch, but we want the most unbranched substituents. Yeah, there's there's quite a few rules here, but we will apply them. Let's see what else we have here. So the CH3s that I circled are methyl groups. And then this here, CH2CH3, is an ethyl. So in this case, I know that my root is ane. I've got 5 carbons, so this is going to be some kind of pentane. And I've got an ethyl attached to carbon 3. So I'll start by saying 3-ethyl. And then 2,3 dimethyl pentane. And note that it is all one word, and I've got hyphens in between and no spaces. Okay, certain names do have spaces in them, like carboxylic acids. Remember, the suffix is oic acid. There's a space there. But for alkanes, it's just one big, long, run-on word. So again, we've got our main chain, 5 carbons. That gives us pent. It's an alkane, suffix ane. We've got 2 methyl groups, so we have a dimethyl, and we have 1 ethyl group, so it's just ethyl. We alphabetize ethyl before dimethyl because the ethyl comes before the methyl. And then we need to indicate where is the ethyl group. It's on carbon 3. So 3-ethyl-2,3-dimethyl, because methyl groups are found on carbons 2 and 3. And it's very important to have the numbers and the correct numbers, even if it seems like they might be redundant, because usually they're not redundant. Okay, let's look at maybe another example or two. So let me go ahead and draw something out here. Okay, so how should I go about approaching this guy? Well, let's go ahead and switch back to the highlighter here. Let me find some carbon chains. I've got 1, 2, 3, 4, 5. Okay. I've got 1, 2, 3, 4, 5, 6. All right, so that's a little longer. I've got 1, 2, 3, 4, 5, 6. So that one, actually, let me redo that one in blue maybe. 1, 2, 3, 4, 5, 6. Okay, so it's not going to be the yellow one because that only had 5 carbons. It's either going to be the blue or the green. And if it's the green, I've got just one substituent. If it's the blue, I've got 1, 2, 3 substituents. So it's going to be the blue one. All right, so let me go ahead and erase those other guys, and we will stick with 2, 3, 4, 5, 6 like that. Now let's go ahead and number these. I'm going to start down here. 1, 2, 3, 4, 5, 6. Now why did I start down at this bottom carbon here instead of on the left like I've been starting? Well, this bottom carbon is closer to a substituent, and this carbon's a little further away. So we can now call this, let's take a look here. Let me circle some groups here. Okay, those are a couple of methyls. And then I'll switch to green here. And this is a propyl group. So I've got methyls on carbons 2 and 3. So 2, 3 dimethyl, 4 propyl, hexane. And so if you wrote that on your exam, you would find that that is wrong. So what have I done that's wrong? Well, let's take a look. So this is an example of, yeah, it's easy to miss something. What if I went 1, 2, 3, 4, 5, 6, 7? So this is not our propyl hexane here. I should have followed this new yellow path. So let me scribble that out. I'll draw it out again. So I kind of jumped the gun a little bit when I was going through here and looking for the longest chain. And that goes to show you that you really do want to take your time and make sure you really do have the longest chain. So 1, 2, 3, 4, 5, 6, 7. All right. And I'll just use my pointer here. 1, 2, 3, 4, 5, 6, 7, compared to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah, so I think I found it now. Okay, but this is something that you'd actually be doing. Let's number these. 1, 2, 3, 4, 5, 6, 7. So now I've got methyls, and then this guy here is an ethyl. So this is, what do we have? 4-ethyl, 2,3 dimethyl heptane. So this goes to show how easy it can be to miss what the actual longest chain is. Now, there's one more thing that I want to mention, and that is sometimes you can have a chain that has a chain coming off, or a branch that has a branch coming off it. So for branched substituents, name as an alkane, but use the suffix YL. All right. So let's say we had the following. Let's say we had CH3, CH2, CH2, CH, CH2, CH2, CH3, CH3, CH3. Okay, so our longest chain here is this one, which is 7 carbons. 1, 2, 3, 4, 5, 6, 7. And if I tried to make a chain that had more substituents, it would be a shorter chain. 1, 2, 3, 4, 5, 6. So we don't want to do that. We want the longest number of carbons in our, the most number of carbons in our main chain. So now, how do we name the branch here? Well, let's take a look at the branch. My branch has 2 branches, so it has that, and then it's got my other methyl group there. So if I number things, let's go ahead and number 1, 2, 3, 4, 5, 6, 7. I'm going to change my color here and go 1, 2. So this here is an ethyl group, but it has an attached methyl group. So we would call that group 1-methyl-ethyl. All right, so I have just named my 1-methyl-ethyl is referring to the substituent. Now I'd put that in parentheses. Sure, these really look like parentheses there. There we go. What carbon is that attached to? It's attached to carbon 4. So it would be 4 there. And then, so 4, 1-methyl-ethyl, 7 carbons heptane. Sorry. Haven't been lecturing on my iPad in a little bit, as you might have noticed. So just to reiterate, we have 1-methyl-ethyl as our branched substituent, and it's attached to carbon 4. Now, this 1-methyl-ethyl group is also called, you may remember from the last lecture, an isopropyl group. So this would be 4-isopropyl heptane. And technically, the 1-methyl ethyl is the correct way to write it. If you say isopropyl, that is okay. So if you use those names for the alkyl substituents, alkyl groups that we looked at last time, names like isopropyl, isobutyl, T-butyl, sec-butyl. If you use those names, that's fine. I mean, everybody knows what a T-butyl group is. All right, so there are some practice problems in the practice problem set, and I have also posted end of chapter problems that are helpful as well. So nomenclature is definitely something that you can, that you should practice. And I will say that, and I'll post an announcement about this as well, I've posted a couple of links to online quizzes where you can quiz yourself on naming things. One works a little better than the other, but I can help you guys out with that as you give them a try. To sort of sum up, in the end, one name should give you one structure. And let me actually erase that, the one structure, and change that to only one. That's probably the most important thing about nomenclature. If I have a name for something, I can draw one unique structure for that thing. It's okay if your one structure has multiple different names. Often they do. You'll have, 1,2-dimethylbenzene, but people will also call it orthoxylene. It's the same thing. One is considered a quote-unquote common name, and one is the IUPAC name. But the most important thing is that your name will uniquely identify just one structure. There should be no ambiguity in the name. Like I can't draw two possible different structures from one name if you've named things correctly. All right, well, go ahead and practice this, and until next time, then stay safe out there. Bye now.